So, now we will do nuclear energy. See, nuclear energy first we have to see here nuclear reactions. You know, in chemical reactions energy is released due to formation of new chemical bonds, whereas in nuclear reactions energy is released due to loss of mass. There is a Einstein's mass energy relation, that is E is equal to mc square, where m is called loss of mass. We can also call it mass defect, and c is speed of light, that is 3 into 10 raised to power 8 meter per second in vacuum. So, whenever mass is lost, that mass gets converted into energy by this formula. So, in nuclear reactions, what happen actually? So, now see, in nuclear reaction, there are two type of nuclear reactions. First one is nuclear fission, another one is nuclear fusion. So, first we will see what is actually nuclear reaction. We have done chemical reaction. In chemical reactions, only outermost electrons of an atom takes part in the reaction and new compound is formed. But what happened here? Identity of the element is not lost. But in nuclear reactions, nucleus of an atom take part in the reaction and entirely new nucleus is formed, new atom is formed, which was not present initially in the reactant atom. So, entirely here identity of the reactant element is lost. So, first one is nuclear fission reaction. What happened here? In nuclear fission reaction, we take heavy elements like uranium, plutonium and thorium. These heavy elements are, simply broken into smaller lightweight nuclei by bombarding slow moving neutrons. During breaking of this big nucleus into lightweight nuclei, a tremendous amount of energy is released. That energy is known as nuclear energy. And you know it, when one atom of uranium undergoes fission, whatever energy is released by this fission is 10 million times the energy released by one atom of carbon on burning. So, you can now see what a big amount of energy we get in nuclear fission reaction. Similarly, what happened in nuclear fusion? In nuclear fusion, what we take here, the two lightweight nuclei are taken. Suppose you have taken 1 H2 plus 1 H2, two lightweight nuclei. These two combine here to form another nucleus that is called 2He3. In this process, again large amount of energy is released. This energy is also known as nuclear energy. This reaction is actually going on inside the sun. So, sun's main source of energy is fusion of hydrogen into helium. So, sun is continuously giving, now you can imagine what amount of energy it is being released by sun. So, there are two type of nuclear reaction, two new sources of energy. But these days whatever the power plants are there in India, they are based on nuclear fission. But that nuclear fission is carried out in controlled manner. If nuclear fission is not controlled, then it will take destructive form, and these we call them nuclear bombs. So, similarly also in the nuclear fusion is uncontrollable till now, there is no device to control. And in nuclear fission, as I have told, it can be controlled. In nuclear power plant, this reaction is being used. But disadvantage of this, main disadvantage is here, during nuclear fission, large amount of nuclear wastes are obtained. These nuclear wastes consist of nuclear radiations, radioactive materials, and we cannot dispose them. So, disposal problem is there with the nuclear wastes, but here in nuclear fusion there is no nuclear waste because it is using hydrogen, but as I have told, it is cannot be carried out in controlled manner. So, we do not use this in power plant till now, in future it can be used.